Welcome to Ratios with Fractions. This is our third day of flipped lessons and our second topic. In a perfect world, we would always work with whole numbers. However, we know we are not always that fortunate. There are fractions everywhere. Seeing as how we occasionally have to use fractions, we also have to write ratios with fractions. So a fraction within a fraction. Could life get any better? This special fraction is called a complex fraction. Easy to come up with because it looks very complex to deal with. Here are some examples of complex fractions. 1/3 over 5, 7/8 is 7 over 8/11, and 3/8 over 2/5. When we are writing these, we should make sure that our fraction bar is clearly written as to separate the numerator from the denominator. Okay, so you can tell which fraction goes in which section. When working with ratios, you must first always make sure that the units are the same for both terms. Let's underline that. If not, you will have to convert them using a conversion factor. Now, there are two ways to simplify a fraction. Set up the problem as a division problem, which will seem easy to you guys and girls. And the second is to simplify the ratios by finding an equivalent ratio where both terms are whole numbers. Now, I prefer this method as it's going to serve you better in the long haul. Okay, it looks difficult now, but it will be better later on in life for you guys. So let's look at this example. We're going to solve it using long division. Your neighbor commutes 12 miles to work, and you commute 9/10 of a mile to school. Write the ratio of your neighbor's commute to your commute as a fraction in simplest form. The first thing we need to look at, we're in miles and we're in miles. So our units are the same. So now we're ready to write a ratio. So we're writing the ratio of our neighbor's commute, 12, over our commute, 9/10. And you can clearly tell where my ratio is in the denominator is the 9/10. So it doesn't look like 12 9ths over 10. It looks like 12 clearly over 9/10. Now we need to simplify this. Okay? Using long division, I can rewrite it as 12 divided by 9/10. You know your rules for dividing fractions. I always do keep, flip, change. Keep, change, flip, or keep, flip, change. Keep it, keep the 12, change it from division to multiplication, and flip it. And now we can multiply. And remember, we want to simplify any numerator with any denominator when we are multiplying. 3 is a factor in both 12 and 9. 3 goes into 12 4 times. 3 goes into 9 3 times. So when I multiply, I get 4 times 10, which is 40. Divided by 3, or 40/3. And we're going to leave it as an improper fraction. Okay? So what does this mean? It means your neighbor commutes 40 miles for every 3 miles you commute. Or you commute 3 miles for every 40 miles he commutes. Okay? So now let's move on to the next example, but we're going to solve it using my method. So we know we have 12 over 9/10. We have that from the last slide. Okay. Think about it this way. We can rewrite it as 12 over 1 all over 9/10. Let's look at the baby denominators here. So here's one baby denominator and here's one baby denominator. The denominators of the baby fractions. Okay. The lowest common denominator of those two fractions is 10. Okay? So I am going to multiply this fraction by 10 over 10. Okay, and I don't want you to write that in your notes yet. I just want you to see it. I'm multiplying by a form of 1, which means I'm not changing my fraction. But it will be helpful for simplification purposes. So when I go to write this, I'm going to write it like this from now on. I'm going to write it by my numerator. Please be clear to make sure you write it by your numerator. So when I go to do the math here, look what happens to this denominator. This denominator right here simplifies. Think of it as disappearing. 12 times 10 is 120. And 9 times the 1 that's there is 9. Now, they asked us for simplest form. So I know that 3 goes into both of these, just like it did on the last example. Remember, we simplified the 9 and the 12 using a 3. Well, 9 and 120 will simplify using with a 3. 3 goes into 9 3 times. 3 goes into 120 40 times. And I end up with 40 thirds. Okay? Like I said, this is a touch longer, and it'll take some practice to get used to, but once you do, you'll love it. You'll find it's much easier. So let's go to the next one. We want to write this in simplest form. We're in gallons, both terms, perfect. So let's find the LCD of the denominator of the baby fractions. The lowest common denominator of 4 and 12 is 20. Okay? If you used 40, you just have a little bit more simplifying at the end, and that's okay. I'm going to rewrite this so that the word isn't in the way. My LCD of 20, I'm going to multiply by 20 here, and I'm going to multiply by 20 here. 4 goes into 25 times. I cleared my denominator. 4 goes into 4 once, so I can put 1 there. 10 goes into 10 once, 10 goes into 20 twice. 3 times 5 is 15. 9 times 2 is 18. And now I need to simplify. 3 goes into 15 5 times. 3 goes into 18 6 times. Okay? How are you doing? If at any point you need to re-look at something, please feel free to pause and rewind it so that you can see it again. All right, try simplifying this one on your own. I got 3 halves. How'd you do? All right, now let's look at this one. This one is a little more difficult. A professional football field is 53 1/3 yards wide, so we're in yards here. Find the ratio of the width of the actual field, so here's our actual, for 53 1/3 yards, to the width of the field in the poster. Poster is 1.5 feet, as a fraction in simplest form. So we need to convert. We can go yards to feet or feet to yards. I'm going to do this as yards to feet. Remember when we did conversions yesterday, the new unit has to be in the numerator. So I have 53 1/3. I don't really like working with mixed numbers, so I'm going to change that into an improper fraction. 53 times 3 plus 1 gives me 160. And then keep your denominator of 3. So I have 160 thirds yards. And I want to convert to feet. And I know that there are 3 feet in 1 yard. My yards simplify. Also, the 3's are going to simplify as well. So when I get 160 feet for my final answer. Now I can write it as a ratio. We are looking at the actual, which is 160 feet, over the poster, 1.5, we can write as 3/2. And now I can do my work. My LCD here is easy. My LCD is 2. Okay? So I can rewrite this as 160 over 1, all over 3 over 2, multiply by 2. And you will notice that I have clearly written the number I multiply by definitely shows up in the numerator. It is on the same line, if you want to think about it. It's on the same line here. It's definitely in the numerator. It's definitely in the numerator. So right here, my 2 simplify. 160 times 2 is 320. And 3 times 1 is 3. So I get 320 over 3. So for every 320 feet of a football field, it would be 1.5 feet, or it would be 3 feet on a poster. So 320 for the actual versus 3 for the poster. Okay, I'd like you to try the next one on your own again. If you got 1 over 24, you did well. For this, but I am going to go through this. For this one, we are working with 6.5 inches in 12.5 feet. I decided to convert feet into inches. So I'm going feet to inches. 12.5 feet. 2 times 12 is 24, and 1 is 25, so it's 25 halves. I might as well convert this here. This is 25 over 4. So let's go. Let's convert this 25 over 2 feet into inches. Inches is my new unit, so my inches have to go in the numerator. My feet have to go in the denominator. There's 1 foot for every 12 inches. My feet simplify. I have a numerator of 12 with a denominator of 2, and I'm multiplying, so I can simplify those. 2 goes into 2 once. 2 goes into 12 6 times. 25 times 6 is 150. So I have 150 inches. And now I can set it up. I want to go with the model to the actual. The model is 25/4. The actual is 150. The LCD is 4. So I'm going to multiply, make sure I'm putting it up nice and high, by 4. These 4 simplify. When I multiply, 25 times 1 is 25. 150 times 4 is 600. And when I simplify that, I get 1 over 24. I'm going to let you in on a little secret. When I had this here, you ended up with 25 over 150 times 4. I simplified here. I know 25 goes into 25 once, and 25 goes into 150 6 times. So I did 1 over 6 times 4 is 24. We always want to do as many tricks like that as we can, so we can use mental math without having to rely on our calculator so much. Okay, and that is the end of the lesson for today. Have a great one.